Good day everyone, I am Lazard and Francisco, and together with me are Mr. Bibera and Mr. Olimpayan, and for this part of our presentation, I'll be discussing the carbohydrate extraction from corn kernels or Zea mays. For the procedures and materials in extracting carbohydrates from Zea mays, we first weighed around 100.2 grams of peeled, washed, and tap-dried corn kernels. These were then homogenized using a mechanical blender with enough water to cover them, and the mixture was refrigerated for 2 days. After refrigeration, we removed the excess liquid, washed the mixture again, and allowed it to stand for 2 hours to let the starch settle. The settled starch was filtered using a muslin cloth and then dried it in oven for 3 days to obtain the pure dried starch extract. For this procedure, we used 100 grams of corn kernels and 100 ml of distilled water. All these steps were actually performed in the lab. In this slide, you can see the step-by-step documentation of our process. We first separated the kernels from the cob and collected 100.2 grams of corn kernels. After homogenizing and adding enough water, we refrigerated the mixture for 2 days. We then separated the residue, filtered the starch using muslin cloth, and oven-dried it for 3 days. From this, we collected 3.1 grams of dried starch, which was used later on for confirmatory testing. For the percentage yield, we recorded the following weights. The corn sample weighed 100 grams, the empty evaporating dish was 36.1 grams, and with the starch, it weighed 39.2 grams. This gives a starch residue of 3.1 grams, and using the formula percentage yield equals to residue weight over fresh sample weight times 100, we obtained a yield of 6.2%. For the organoleptic evaluation, the starch extract we obtained appeared to be white in color, granulated in texture, and was solid in physical state. It had a bland taste, which is atypical for purified starch. All of these were actual results made during our laboratory. In the solubility test, we checked if the extract starch dissolved in water, and the results showed that it was insoluble in water, which matches the expected property of starch. For the identification test for starch, first is the starch mixture formation. So when mixed with water and boiled, the extract formed a smooth, thick, and translucent paste, which indicated starch gelatinization. Next is the pH determination. For pH testing, we used distilled water and red litmus paper, and there was little to no color change, showing a pH close to neutral around 6 to 7. This means that the starch is stable and safe for food use. Next is the iodine test for starch. In the iodine test, when the iodine solution was added, the sample turned purple, confirming the presence of starch in the extract.
Moving on to the answers to questions part. Number 1, what are the 3 main categories in the classification of carbohydrates according to the size of their molecules? So the 3 main categories of carbohydrates based on the size of their molecules are monosaccharides, disaccharides, and polysaccharides. So monosaccharides are the simplest sugars made up of 1 sugar unit. Disaccharides have 2 sugar units, while polysaccharides are composed of many sugar units linked together. Number 2, in Benedict's test, varying colors from green, yellow, red, or brown indicated the presence of carbohydrates depending on the concentration of sugar. What compound is formed during this chemical reaction? So in Benedict's test, the compound formed during the chemical reaction is cuprous oxide. It appears as a colored precipitate when the reducing sugar reached with the Benedict's reagent. So the color changes from green to red depending on the amount of sugar present. So this shows the presence and concentration of reducing sugars in the sample.
The extraction of starch from corn was successfully accomplished as confirmed by both starch mixture formation and iodine test. The smooth, thick, translucent paste observed after boiling and cooling indicate that starch gelatinization verified the presence of starch in the corn extract. The iodine test further supports this result through the appearance of purple coloration, a characteristic reaction of starch with iodine solution. Additionally, pH determination show a near neutral value with a minimal color change in the red litmus paper, indicating the extracted starch is chemically stable and safe for food application. Overall, the experiment effectively demonstrates the successful extraction and identification of starch, the primary compound used in detecting